Let us solve a question on how to find out the level of output where marginal cost is minimum. The question is, when average variable cost is being given as says AVC is equal to 10 minus 5Q plus 10Q square. Q denotes the output. We have to find out the level of output where the marginal cost is minimum. Options are being given. We need to find out the correct option. Okay. So what we are being given here? We are being given the average variable cost, that is AVC is equal to 10 minus 5Q plus 10Q square. This is our average variable cost. Okay. Now we have to find out the marginal cost first. Okay. So we have to find out what will be the marginal cost function. To find out the marginal cost function, first we should know what is the total cost function. Okay. Now, since we are being given the average variable cost here, first we need to find out the total variable cost. And what will be the total variable cost? Total variable cost will be equal to average variable cost times output. That means this average variable cost, that is 10 minus 5Q plus 10Q square. To this we multiply by Q. This will give us total variable cost as 10Q, multiplying this Q to each of these terms, minus 5Q square plus 10. Here it is Q square. Okay. So Q square into Q is Q cube. This is our total variable cost. Okay. Now what is the total cost then? Total cost is actually the aggregate of total variable cost plus total fixed cost. Okay. We assume any number, any constant as total fixed cost, because total fixed cost is not being given here. Then our total cost function will be equal to, that is total variable cost, that is 10Q minus 5Q square plus 10Q cube. In place of TFC, I can write any constant. Let's denote K as any arbitrary constant. This is our total cost function. Next, we need to find out the marginal cost function first. Okay, what is marginal cost? Marginal cost is the derivative of total cost function with respect to output. Okay, so we differentiate this function and let's write it here. So our marginal cost will be equal to derivative of this function with respect to Q. Derivative of Q will be 1, so we are left with 10. Derivative of Q square is 2Q, so 2 into 5 is 10Q. Then derivative of Q cube is 3, becomes coefficient, so 3 tens are 30 Q, and exponent is subtracted by 1. And derivative of a constant we know is equal to 0, so derivative of K will be 0 here. So this is our marginal cost function. Graphically, what exactly we have to find out, and let's draw a simple graph. We have output on this side and marginal cost on this side. Okay, let us draw. If I draw this curve, it will look like this. Okay, this is marginal cost function. Okay. Now we need to find out the level of output where marginal cost will be minimum. Since this is the marginal cost function, the level of output will be minimum at a point where the slope of the marginal cost is 0. Okay, and let's write it here. I will write marginal cost will be minimum where slope of marginal cost function is equal to 0. Now what is the slope of marginal cost function? That is the derivative of this marginal cost function with respect to output, and we set it equal to 0. So slope of marginal cost means the derivative of marginal cost function with respect to output. It should be equal to 0. So we differentiate this marginal cost function with respect to q. Derivative of a constant is 0. Derivative of q will be 1 here, so we are left with minus 10. Here it is 30 q square. Sorry for the mistake. And derivative of q square is 2q, so 2 into 30 is 60. We write it here 60 q and we set it equal to 0. Okay. Solving for q, it implies 60q will be equal to 10, which implies dividing both sides by 60, we will get q will be equal to 10 upon 60. So 0 gets cancelled. We are left with 1 upon 6. That means marginal cost will be minimum when the output level is 1 upon 6. And let us say this point, you notice this 1 upon 6, because at this point the slope of marginal cost is 0. Now this is only one condition. To be sure whether this point is minimum point, we need to check the second order condition. Second order condition simply tells us that we take the second derivative of marginal cost function, and if that comes out to be positive, then we have actually the minimum point at q is equal to 1 upon 6. That means for second order condition, we take the second derivative of marginal cost function, that is d square mc, the second derivative of marginal cost function with respect to output, that is dq square. And if that comes out to be positive, then we have and the second order condition for minimum is satisfied. So since this is the first derivative of marginal cost function, the derivative of this function again gives a second derivative. Derivative of a constant is 0, derivative of q will be 1, so we are left with 60. Since 60 is greater than 0, we say that second order condition is satisfied for minimum. Okay, so the output level where marginal cost is minimum will be 1 upon 6. I hope I make myself clear in this video. Thank you.